Now, let's discuss the sample problem number 2. As usual, we'll start by listing all the given values, and then we'll identify whether the curve is symmetrical or unsymmetrical. Looking at the problem, it is clearly stated that the curve is symmetrical, so we can proceed with that assumption right away. We are given two roadway grades, plus 4.2%, which we'll assign as G1, and minus 2.1%, which will be our G2. Now, take note, since the grade changes from positive to negative, this indicates that the curve transitions from an upward slope to a downward slope. Another given is the rate of change of grade, which is 0.35%. Also, the point of vertical tangency or PVT is located at station 5 plus 020 and its elevation is 124.36 meters. The first requirement of this problem is to determine the length of the vertical curve. Using the rate of change of grade formula, substitute the values given and compute the value of n. Then the value for n is 18. To determine the length of the vertical curve, L, we will multiply 18 to 20. The value of L is therefore equal to 360 meters. Now, the next requirement of this problem is to determine the distance of the highest point from the beginning of the curve or PVC, which is S1. Using the formula of S1, substituting the values, we will get the value of which is 240. Therefore, the distance of the highest point from PVC is 240 meters. Next requirement of the problem is to compute the elevation of the highest point on the curve. To do this, let's first illustrate the parabolic curve for better visualization of creating your formula. Include in the illustration the given stationing at PVT, which is 5 plus 020, and its elevation of 124.36 meters. Also, we may include the length of the curve from the computed value, which is 360 meters. Since the parabolic curve is given as symmetrical, we may also show the same value of left and right side length, which is 180 meters. Now, from the calculated location of the highest point from PVC, S1, which is equal to 240 meters, we will also show it to the sketch and determine what equations we need to determine its elevation. Since the given reference elevation is taken at the PVT, we will begin by forming our equations based on this point. First, we construct a triangle starting from the PVT. The top of this first triangle corresponds to the station of the PVI. Next, from the PVI, we draw another triangle extending upward along the grade until it reaches the highest point, HP. Finally, from this point, we project a straight line downward to locate the highest point of the curve, where we can then determine its elevation. Now, let's determine the height of the first triangle. The base is 180 meters, and we'll denote the height as y1. The slope of the hypotenuse is given as 2.1%. Using the slope relationship, we compute y1 as 180 multiplied by 0.021. This gives us a value of 3.78 meters. Next, for the second triangle, let's first determine its base, which will be named as x2. From the illustration, the base can be obtained by subtracting 180 meters from S1. So, we express it as x2 is equal to 240 minus 180. This gives us a base of 60 meters. Now, let's illustrate the second triangle and determine its height, y2. The base is 60 meters, and the slope of the hypotenuse is 2.1%. Using the slope relationship, y2 is equal to 60 multiplied by 0.021, which gives us a value of 1.26 meters. Lastly, we need to determine the vertical distance from the base of the second triangle up to the highest point on the curve, which we will denote as y3. Using the parabolic property, the relationship can be expressed as y3 over the square root of x3 is equal to h over the square root of L over 2. However, before solving this equation, we first need to determine the value of h, which represents the total height of the curve. The formula for the height of a symmetrical curve is L over 8 multiply them to G1 minus G2. Substituting the given values, we have h is equal to 360 over 8 multiplied by the difference of 0.042 and negative 0.021. Solving this, we obtain a value of 2.835 meters. Next, let's determine the value of x3, by referring to the illustration of the parabolic curve. Therefore, we can express it as x3 is equal to 180 minus x2. Substituting the value of x2, we have x3 is equal to 180 minus 60, which gives us 120 meters. Now, let's go back to the illustration and visualize the equation. Starting from the reference elevation at the PVT, we move upward to the PVI through the first triangle, then move downward along the second triangle, and finally go down from the base of the second triangle to the highest point of the curve. From this, we can form the equation. The elevation of HP is equal to the elevation of the PVT plus y1, minus y2, minus y3. Substituting the given values, equals 124.36 plus 3.78 minus 1.26 minus 1.26. This results in an elevation of 125.62 meters. Therefore, the elevation of the highest point of the curve is 125.62 meters. And that's how we determine the elevation of the highest point of the curve. Try reviewing the steps and solving a similar problem on your own to strengthen your understanding. Keep practicing, and I'll see you in the next video.